All right, I've had a few questions regarding what type of a bond or what type of a compound it is if you have one of these polyatomic ions involved in the question. And correctly so, let's take a look, say, at ammonium, that one right there. So the symbol is NH4 plus. That plus indicates that it has or an interest in giving away an electron, or the plus actually means it's lost an electron, so that the balance of this compound is it's sort of short an electron. But when you look at it, you have nitrogen, which is over here, which is a nonmetal, and hydrogen we typically classify as a nonmetal as well. So how can an NH4, if it's one of these over here, how can it be a type 1 compound if you're dealing with nonmetals? And here's why. So some groups of nonmetals like these, or there's other ones here, sulfur or nitrogen trioxide, well, that one's called nitrate, but nitrogen and 3 oxygens, and there's a bunch of other ones here, where all they are nonmetals that are grouped together. Sometimes when nonmetals group together, for example, carbon, you can form a stable compound if you have 1 carbon and 2 oxygens. But you can also form a compound which isn't totally stable, but that it has a charge. So when the 1 carbon and the 3 oxygens get together, they seem to be happy joined together, but there's a resultant charge. They have 2 extra electrons. So that's a carbonate ion. And so whenever you have any of these complex ions involved in a compound, it would depend on who they hook up with. Typically, if they're a positive charge, like NH4+, are there any other plus ones? I don't see any other plus ones there. Anyway, NH4+, it is, because its charge is a positive, it's going to mimic a metal over here. And it's a positive 1, so it's actually going to mimic anything that's in this column here that has a 1 plus charge, or they're wanting to get rid of an electron. So that's ammonium. Any of these other ones, so there are lots of more nonmetals that are hooked together with a resultant charge. All of those mimic a nonmetal over here. And so if, say for instance, let's go with hydroxide. If hydroxide hooks up with, let's hook it up with ammonium. So if I have ammonium and it hooks up with hydroxide, ammonium is a positive charge, hydroxide is a minus charge, so those cancel out. So the formula is just NH4OH. When those get together, this thing here is mimicking anything in this column. And so since there's only 1 charge, ammonium only has 1 option for a charge, that would be a type 1 compound, where you'd name it with type 1 nomenclature. Now, if you had something like this hydroxide, and if you were to hook it up with, say, somebody like iron, there's iron. See, iron's got 2 options for a charge. So if you hook it up, say, with the 3 plus charge, so if I hook iron 3 plus with hydroxide, I have to balance the charges. So in order to balance the charges, I need 3 total of those. So I'd have FeOH3. I would name this one, because iron could be a 3 plus or it could be a 2 plus. I would name this using the type 2 rules for nomenclature. So this one, you'd have to say, well, which of these 2 are you using? I was using the 3 plus, so this name would be iron. I don't know if you can see what I'm doing there, sorry. So this one would be named iron, since I'm using the 3 charge, iron 3 hydroxide. Okay, hopefully that gives you an idea then just sort of how to deal with compounds that may have these complex ions in them. So the complex ions, they'll mimic either a metal or a nonmetal, and then depending who they're hooked up with will depend whether you have a type 1 or a type 2 compound. And the type 1 compounds are any of these that only have one charge to them. If there's only one charge, whatever it hooks up with is going to be a type 1 compound. But as soon as you get some like this one, or this one, or this one, you can see all the ones that have two. There's one. So any of the ones that have multiple charges there, then you have to use the type 2 names or rules to name those compounds. All right, hopefully that helps you out.